Hello, good morning everyone. See, welcome back to our e-learning session, and it is initiated by Vidyadesh Vidya Sankul under the guidance of Dr. G. M. Sutaria sir. Okay, see, in our last lecture we complete our illustration number 10 up to illustration number 10, as well as some new formulas and some new points, right, regarding probabilities, right, 1 through 3 points, and for first of all the assumption, then the points, that is 6 points under that different formulas we show that in our last lecture, and we will continue with our illustration number 11 in this lecture. Okay, now see, I hope you complete your homework, that is up to 1 to 10 example book is over, as well as 1.1 exercise is also over, and you all remember all the formulas whatever up to this in this chapter I am giving you. Okay, so if not, then please remember, please learn that all the formulas. Okay, now we'll start our lecture. Okay, so here we'll start our 11 example. I am reading that illustration number 11. See, if two balanced coins are tossed, what is the sample space for that? Two balanced coins, right? See, we have to find out first that what is the sample space of given experiment. That is, here two balanced coins are tossed. Then find the probability of first getting one head and one tail. That is your first event. See here, whenever the first question is given, then here you have to find out first sample space of that particular experiment, and then you have to find out 1, 2, 3, 4 the remaining, that is your different types of events. Here first event is getting one head and one tail, and the second event, that is event B, is getting at least one head. What means of that? We will see that here. Please concentrate on this. First of all, we have to write down illustration number 11, the sample space of the experiment two coins tossed. What is the sample space? That is U is equal to what? Head, tail. Sorry. First of all, in both the coin, head is there. So head, H. Now on first coin, head is there, and on the second coin, tail. That is the second outcome. What is the third outcome? That is, on first, tail is there, and on the second, head is there, and on the both, tail is there. That is your fourth outcome. So whenever you are tossing a two coins simultaneously, what is your total outcomes? That is, what is your sample space? Here in one coin, head is there, and in the second coin, head is there. So your first answer, your first outcome is head, that is H. Second experiment, second event, what is the second outcome? H, that is head on the first coin and tail on the second coin, that is HT. Now the tail on the first coin and the head on the second coin, that is your third outcome, that is TH, and the last outcome is tail. Both in the both coin tail is there, so total outcomes is 4. How? See how we have to find out. See, n is equal to, see what is the total outcome of the experiment of one coin toss. What is the total outcome? That, see here 2. Why 2? Head and tail. See, at the time of head and tail, that is at the time of tossing a coin or at the time of throwing a die. See, we have to keep in mind one thing, that here what is the total outcome of tossing one coin? That is 2, head and tail. Whenever we are doing a simultaneous experiment of one coin or simultaneously at the same time we are tossing one or more coin, then what is the total outcome? See, we have to write down the raise to here. What means of that? What is the raise to? That means here if 2 coins, then your total outcome is 2 raised to 2. If 3 coins, your total outcome is 2 raised to 3. If 4 coins, your total outcome is 2 raised to 4. Why? 2 is the final answer, because whenever you are tossing a coin, the final answer is, your final outcome is head and tail, nothing else. Okay, it is certain event. Head and tail is the final outcome of any coin, right? So here whenever 2 coins, you have to write down 2 raised to 2. Whenever 3 coins we are tossing, then you have to write down 2 raised to 3. 4 coins, you have to write down 2 raised to 4. Your total outcomes is multiple with the 2. Multiply with 2, because your final answer of tossing one coin is 2. If 2 coins, then 2 raised to 2, 3 coins, then 2 raised to 3, 4 coins, then 2 raised to 4. Right? Okay, get it? Now, in the same way, whenever you are throwing a die, total outcome is 6, right? 2 dice, then your total outcome is 6 raised to 2. 3 dice, your total outcome is 6 raised to 3, because the final outcome of any one die throw is 6. That is, on the balance die only 6 numbers are there, 1 2 3 4 5 6. So whenever you are throwing one die, that is your final outcome is 6. If you are throwing 2 dice, then 6 raised to 2, 3 dice, then 6 raised to 3. Same way. Always keep in mind here the main thing, whenever the die and the coin example is given, you have to find out what is the how many number of coins or how many number of dice are thrown, and that's on that day we have to find out what is your total outcomes. Here if one coin is there, what is your total outcome? That is 2 raised to 1, that is 2. Right? So if one coin, head and tail, 2 coin, head tail, tail, right? 3 coin, first H, then HTH, THH, and so on. That's why we can say if 3 coins are tossed, then 2 raised to 3 is your final answer. Okay, so in practical examples, now we will start our practical examples which ask in the board, in the examinations. Whenever theory portion, see the main theory portion is over, now some theories are remaining, but the main theory which will ask in your examinations will over. Okay, so here now we will concentrate only on the practical sums, and it is most important. Okay, so please be alert. Okay, now see, I am first of all write down this is not your this sum answer, but this is your one note that you have to remember during the total full chapter. Okay, So first of all, write down this. 1 die, n is equal to 6 raised to 1, that is 6. 2 dice, n is equal to 6 raised to 2. 3 dice, n is equal to 6 raised to 3. That is total outcome of this experiment. Same way, 1 coin, 2 raised to 1, 2 coins, 2 raised to 2, 3 coins, 2 raised to 3, and 4 coins, 2 raised to 4. That is total outcome of the experiment given into the example. So here again the answer is 4. Total number of outcomes is 4. Okay. Now what is your first event? See that getting one head and one tail, right? So here first point, event A is equal to getting one head and one tail. So favorable outcomes of event A is equal to M is equal to, see what is the favorable outcomes from the sample space for the event A, that is one head and one tail. See, it is not perfectly asked that on first coin it is head, on the second coin it is tail, or on the first coin it is tail, or on the second coin it is head. See, only the question is getting one head and one tail. That is on which coin, what is that, we don't mind. Okay, so here head tail and here also head tail head. So one tail and one head, that is here we have to write the total outcome is HT and TH. So it is 2 in the numbers, right? What is your sample space? HH, HT, TH and TT, right? What is the event A? We want getting one head and one tail. What is the favorable outcomes of event A? That is M. M is equal to what? HT and TH, one head and one tail, one head. Okay, so here total outcome is 2. So what is your probability? See, probability is equal to, that is P of A is equal to M upon N is equal to, M is equal to number is equal to 2 and N is equal to 4. So we can write here, make a common 2 from this, that's why 1 by 2, right? Take a common 2 here, 2 1s are 2 and 2 2s are 4, that's why 1 by 2 is your total probability of getting one head and one tail. Okay, so here your first answer, that is event A, is over. Required probability is 1 by 2. Therefore, we can say, therefore, required probability is equal to 1 by 2. Now the event B. At least. What means of at least? See, I told you whenever I am explaining you the union event, I have always told you that, see, whenever the at least word is there, you have to write down union of the event. What means of that? Here, not here, union, at least one head. See, union is made only when two events are there, that is event A as well as event B. Okay, so whenever event A and B is there and the word at least is there, you have to find out A union B. But here we just have to find out only event B, not any union, that is A union B. So here what is the answer? At least one head from this. At least one head means what? More than one head, it is allowable, right? It is a favorable outcome if more than one head is there, but minimum one head is compulsory for the favorable outcome in the event B, that is at least one head. If zero head is there, then it is not a favorable outcome of event B. Okay, so this is the meaning. So we can write here favorable outcomes of event B, M is equal to C. At least one head, that means more than one head, it is allowable, it is a favorable, right? So here two head is there in first outcome, it is two head, it is favorable for this. Yes, at least one head, in that more than zero, not zero only, more than zero head is there only. Okay, so head, that is HH, then HT, and then TH, that is 3. In this, see, two heads are there, at least one head, it is satisfied the definition, it is the satisfied the event main thing, that is at least one head. Yes, more than one head here. Okay, then it is favorable. Here HT, one head is there. Yes, here TH, one head is there. Yes, that's why. And in TT, no head is there, so it is not a favorable. Tail is not favorable event outcome for the event B, that is at least one head. Okay, so here three outcomes are favorable from 4. So P of B is equal to again M upon N, that is 3/4. M is equal to 3 here, and the total outcome is always common for, that is sample space is always common. Right, here sample space is common, and that's why total outcome is also common for one experiment. Only in the event the favorable outcomes will change. So denominator is always common, that is N is equal to 4. We have to first find out the denominator. Into each and every question we have to first find out the denominator, that is total outcome of the particular experiment, and then we have to find out event A, event B, and so on. That is, we have to find out the favorable outcomes of event A, event B, that is M for that particular event, M for that second event, and find out the probability, that is P of A, P of B is equal to M upon N. M upon N is equal to 2/4, here M upon N is equal to 3/4. But here we can find out the common from this, that's why cancelling 2 here, 2 ones are 2 and 2 twos are 4, that's why final requirement of the probability is 1/2, and here the required probability is, therefore we can write down required probability is equal to 3/4 is the final answer. So here very easy question and very easy sum, that is 2 mark sum is here. Please write down this first of all, and then we will discuss about the next example, that is example number 12. So first of all write down this. One minute. Okay, complete. Now illustration number 12. See that? Now die, question of die is there. two balanced dice marked with numbers 1 to 6 are thrown simultaneously, find the probability that first of all we have to write down the sample space. So U is equal to what? Is equal to 1ij. That is 1 1 1 2 1 2 1 3 1 4 1 5 1 6 and so on. That total 36 number of outcomes for this sample space U. Okay, so here ij is equal to what? One, two, three, 4, 5 and 6. U is equal to ij, that is ij is equal to 1 2 3 4 5 6. And what is the total outcomes? We was discussed about that is 1 1 1 2 1 3 1 4 1 5 and 1 6, then 2 1 2 2 2 3 2 4 2 5 and 2 6. That means here what we can say, that here n is equal to what? 6 raised to 2, that is 36 is the total outcome for this experiment. Okay, so here I am not writing that particular 36 outcome, we already discussed about that, that's why. Okay, so here what is the 36 outcomes? 1 1 1 2 1 3 1 4 1 5 1 6, that is 6. 2 1 2 2 2 3 2 4 2 5 2 6, that is again 6. 3 1 3 2 3 4 3 3 3 3 4 3 5 and 3 6, then 4 1 4 2 4 3 4 4 4 5 and 4 6, 5 1 5 2 5 3 5 4 5 5 and 5 6, and the last 6 1 6 2 6 3 6 4 6 5 and 6 6. If you don't remember that, then please write down these total outcomes, total 36 outcomes. Okay, it will help you to find out the remaining answers. Please write down in your fair book your total outcomes, that is U is equal to total 36 outcome. Okay, and here n is equal to what? 6 raised to 2, because two balanced dice are thrown simultaneously, 6 for one, 6 for second and 6 into 6, that's why the total outcomes is 36. Okay, now the first event, that is first point, A1, event A1 is equal to what? The sum of the numbers on both the dice is 7. See, sum is 7. So what is the favorable outcomes? Of event A1 is equal to M is equal to, see, I am writing that particular all the outcomes for which are favorable for event A. See, 1 6, here the total is 7, 2 5, again the total is 7, then 3 4, total is 7, then 4 3, total is 7, and then 5 2, total is 7, and then 6 1, total is 7. That's why here 6 outcomes are favorable. We can say that total 6 outcomes are favorable here. Okay, so what is your P of A1? probability of A1 is equal to M upon N. What is the favorable outcomes? That is 6. What is the total outcomes? That is N is equal to 36. So if making common 6 here, 6 ones are 6 and 6 six are 36, the final answer is 1 by 6. So we can say that required probability is equal to 1 by 6. For event A1, sum of the numbers on the dice, both the dice, that is 7. See the total outcome, the favorable outcomes for number 7, total sum is 7, is 6. And that's why probability of A1, that is P of A1 is equal to M upon N is equal to 6 by 36, that is 1 by 6 is the final answer. Okay. Now, what is the second? Sum of the numbers on both the dice is more than 10. Here A2, event A2 is equal to sum of the numbers on both the dice is more than 10. See the what is the highest total and what is the lowest total on both the dice. I told you at the time of experiment, I am explaining you that what is I am explaining. See 1 1, that is 2, is the smallest total, and 6 6, that is 12, is the highest total of these experiment. Whenever two balanced dice are thrown simultaneously, here the total outcomes, the sum of the on the outcome is minimum total is 1 1, that is 2, and the maximum total is 6 6, that is 12. Right? So here the total is between 2 to 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. But here what we want, the dice, on the dice the sum is more than 10. Right? More than 10 means what? Here 10 we cannot take. So what is the remaining? That is 11 and 12. Right? Total on both the dice is 11 and 12. It is indirectly asked that here we want to find out the favorable outcomes of the event A2. That is the total on both the dice is 11 or 12. More than 10 means what? More than 10 only two numbers are there, that is total are there 11 and 12, because the highest total on two dice 6 plus 6, that is 12. That's why only two sums are there. Now what is the favorable outcome? We have to write down first of all favorable outcomes of event A2 is equal to M is equal to, see the total is 11, how? 5 6 6 5 and then 6 6. Total is 3. Okay. So here favorable outcomes of event A2 is equal to 5 6 6 5 and 6 6. Okay. So now P of A2 is equal to what? M upon N is equal to 3 upon 36 is equal to 1 by 12. 3 ones are 3 and 12 threes are 36. That's why we can write down that required probability is equal to 1 by 12. Okay. So here your second question answer is also over. Now the third one, see that sum of the numbers on both the dice is at the most 4. See, what is the lowest total? That is 2. I also here I am already told you that 1 1. The lowest total is 2 and 6 6. That's why the highest total is 12. We want at the most 4 total. That means we want highest 4 total. Lowest 2 is there. So we can say that the total here finding out is 2, 3 or 4. Okay, at the most 4 means what? Lowest 2. So starting from 2 total, then 3 and 4, not more than that. At the most 4 means highest 4. At least 10 means lowest 10, more than that. Okay, so please keep in mind all these words. At the most means we have to find out the lowest one from that, and at least means that is the minimum. We have to find out the greater than or more than that. Okay, so please keep in mind. Please see the theoretical questions we have to see. We have to convert this theoretical question into practical one. So here we have to understand what they want to ask and what is our answer. At the most 4 means what? Here we want the highest total, that is 4, but here starting point is 2. That's why 2, 3 and 4. We have to write down the favorable outcomes of total, that is sum on the 2 dice is 2, 3 or 4. Okay, so I am writing now that is event 3, event A3 is equal to sum of the numbers on both the dice is at the most 4. We have to concentrate on this particular word, at the most 4. So here what is the favorable outcomes? See, the total minimum total is 2, that is 1 1, then 1 2, that is 3, 1 3, that is 4, 2 2, 2 1, sorry, 2 1, that is 3, 2 2, that is 4 and 3 1, that is 4 again. So the total outcome, total favorable outcome is 6. Okay, so total favorable outcomes for this event is 4, and now that's why we can say that P of A3 is equal to M upon N is equal to 6 by 36, that is 1 by 6, and that's why we can say required probability is equal to 1 by 6. Why? 6 is common here, and that's why we can say that the required probability is 1 by 6. Okay, so first of all, 3 events, that is A1, A2 and A3 are over. So first of all, write down these all 3 events, and then we will discuss the remaining 4 and 5 and 6, remaining 3. We are discussing remaining 3 after that. Please first of all write down all these into your fair book. Okay, I hope you complete this. Please complete this. If you are not write down this, then please pause the video. I am removing here all these things, right? Okay, now the fourth one, event A4, right, is equal to both the dice shown same numbers. What is the favorable outcomes of A4? That is M, same numbers. What means of that here? 1, 1, then 2, 2, then 3, 3, then 4, 4, then 5, 5, and then 6, 6. So total 6. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Both the dice shows same numbers. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So your favorable outcomes of, the probability of here P of 4, A4 is equal to M upon N is equal to 6 by 36 again. And the required probability is 1 by 6. That is common. We are taking common from these. 6 ones are 6 and 6 6 are 36. Therefore, the required probability is 1 by 6. Okay. So here easy. Now next point, fifth point, sum of the numbers on both the dice is 1. See, minimum total is 2 and the maximum total is 12. Here event A5 required that the minimum total, that is sum of the total on the both the dice is 1. It is impossible event, right? Because the minimum 1 1 is on the both the dice, and that's why the total, that is sum, is minimum sum is 2. If the required sum is equal to 1, that means it is an impossible event. What means of that? Here minimum total is 2, maximum total is 12. If event A is required less than 2 or greater than 12 total, that is sum on the both the dice, that all events are called an impossible events. Okay, so here I have to write that particular event, that is A5. Here sum of the numbers on both the dice is 1 and it is an impossible event. That's why here favorable outcomes of event A5, M is equal to 0, because it is an impossible event, and that's why we can say required probability is 0 by 36, that is 0. See, the total probability, I always told you that the total probability is between 0 to 1. It is into the point, it is in fraction, right? So here the total probability is 0. Yes, whenever the impossible events are there, the total probability is 0, and whenever the certain event are there, that means here the probability is always 1, and between that the remaining events are fraction of 0 to 1. Okay, 0 0.5, 0 0.2, 0 0.8, 0 0.75, that are the answer of these probabilities. Okay, so always probabilities answer is between 0 to 1 whenever the impossible events are there. Here impossible event is there, that's why the answer is 0. And in the next, that is in the last, see that sum of the numbers on both the dice is 12 or less. See, it is a certain event. How? Sum of the total on both the dice is 12 or less. See, always minimum total is 2, maximum total is 12, and if we want as an event outcome, favorable outcome, that we have to find out the sum on the dice on both the dice is less than 12. That means all the 36 events outcomes are the favorable outcomes for this particular event, because minimum total is 2, maximum total is 12, and here we want as a favorable outcome of this event is sum of the both the dice is less than 12. 12 or less than 12, not only less than 12. If less than 12, then 35 outcomes, because 6 is the total, that is 12, right? But here we want 12 or less. 12 or less means we want 12 as a total also on both the dice. So all the events, all the outcomes 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 1 then 2 1, 2 2, 2 3, and so on. All the 36 outcomes are here favorable for this particular event, because event A6 says that sum of the members on the both the dice is 12 or less. So here the favorable outcomes of event A6 is equal to M is equal to all 36. So here P of A is equal to what? M upon N, and that's why we have to write down 36 by 36, because M is equal to 36 as well as N is equal to also 36. So your final answer is 1. Your required probability for this question is 1, and for this question is 0. Okay, so here illustration number 12 is complete. So please write down this. This is your point number 5. This is your point number 6. And here the main important thing is we have to always remember the total outcome, that is 36, because in all the probability we have to write down that as a denominator. Okay, so please see that and write down this. Here your illustration number 11 and 12 is over. And time for homework. Exercise 1.2, question number 1 and 2 is your homework. So you have to do 11 and 12 two example in your example book, as well as 1 and 2 question of exercise 1.2 in your exercise book. Okay, so here I am complete my lecture, so please write down these and then have a nice day. Bye bye. Good day.